Hello everyone, in this video I'll be sharing about solution. So let's start. Solution means it is the homogeneous mixture or of two or more than two components. That means it can be a mixture of, it can be either two or it can be more than two components. So let us take an homogeneous mixture. Let us say this solution is a homogeneous mixture. I have added here salt and water, so and mixed it together, and this solution is called your homogeneous mixture. So homogeneous mixture means its composition, whatever the composition is present in the solution, will be uniformly distributed all over the solution. In the entire solution, its composition will be uniformly, that means equally distributed. Now, to make it more clear, let us take another solution, that is heterogeneous solution. Let us say if we mix oil and water and stir it, and we will find after sometimes that some of the oil particles will be floated over the solvent, and if we check they are not uniformly distributed. So this is called your heterogeneous solution. They are not properly mixed up. Okay, so this is called your heterogeneous solution. Now in this chapter we are going to deal with the binary solution only. That is, binary means two components only. So whatever you mix, if the components is two, that is called your binary solution. Here I have just taken two components, A and B, or we can say NaCl plus water, glucose plus water, and many others. Okay, so now we will go to solution. Binary solution once again. So binary solution means two components only. So in these two components, one may present in larger amount and the other may present in less amount. The one which is present in larger amount is called your solvent. Okay, and the other which is present in less amount is called your solute. So solution means solute plus solvent. We can separate in this the two components in this form, solute plus solvent. So solute means less amount, less quantity. So when you this concept will be helpful in solving numericals. Like in the question, you may find like 2 grams of NaCl is dissolved in 100 ml of solution. So remember that from this, the less amount is your solute and the greater amount will be your solvent or solution. Okay, here it is solvent. Now let us say the amount. When we talk the amount of the solution, let's say we have added the glucose. We make a solution of glucose at home, right? So when we make this solution, we don't think about how much quantity shall we add. We just add 1 spoon or 2 spoon according to our likes. So when the amount of the solvent water is more large amount, then we say it's very dilute. The amount of this glucose present is less, or the amount of solute present is less. Or if the amount of the glucose is more, then we say it is more concentrated. So we use this term like dilute and concentrated. Okay, high concentrated means the number of solute is present much more. Okay, so this amount of solute, now the amount of solute present in the solution, can be used by the terms concentration. Like when we go in the market buying all the stuffs like potatoes or any other, we use the terms like kg, grams, so that we know the exact amount. In that way, the amount of solute that is present in the solution can also be known by concentration terms, and these terms are the qualitatively or it can be quantitatively. So when we say qualitatively, it is just, oh, the solution is very dilute, or we say is more concentrated. Now it is very confusing, right? Because for someone it may add 3 spoons of sugar, we cannot get the exact value. But when we go for quantitatively, we can calculate the exact amount, and we can get the exact amount which is dissolved in the solution. Okay, so this quantitatively, that the concentration terms are, we can express in different forms. That is the mass percentage. Okay, so mass percentage. So W by W, here it is mentioning, very important part here, W by W. W means mass, W is also mass. When we say mass percentage, okay, so mass percentage term is there, so into 100, mass of the component present in the solution. Okay, so mass of the component means, see, it can be mass of the solute or it can be mass of the solvent. So mass of the component means what? It can be solute or it can be solvent. So mass of the component either solute or solvent by total mass, W by W, so it is total mass of the solution into 100. Okay, so above it will be always your component present in the solution, and below will be your always total, and since it is W by W, it should be always mass. Now then let us know this, because these terms we are going to face while doing our solving our numericals. 10% glucose in water by mass. Whenever we see by mass, then remember it is W by W. Okay, 10%. Let us do in this form 10 by 100. So 10, this 10 will be your solute, and this 100 will be below will be your solution always. That also in which form? It is in gram, and it is also in gram. So below will be your solution, that means solute plus solvent, and above will be your solute, W by W means. Okay, so 10% glucose in water means 10 gram of the solute is dissolved in 100 gram of the solution. Okay, solution. Student get confused whether it is solvent or solution. Okay, so remember this, below will be always your solution. Now in the next case, we will also use the concentration terms, that is volume to volume, that means V by V. Volume percentage means percentage is always with 100 multiplying. So above will be volume of the solute, So solute here means it is in which form? Volume means it will be in ml. Okay, it will be always in ml, and volume of the solution, that also will be ml. Okay, so 10% ethanol in water, so you have to know this term also, ethanol in water. So we are going to add ethanol in water. Okay, this will be your water. So this ethanol will be your solute, and this one water will be your, okay, ethanol will be your solute. So 10% ethanol in water means you have to know this term. So that means 10 by 100 V by V. So this 10 will be your ml, because volume of solute, above will be always solute, below will be your solution. So this is your solution, but in what unit? This is in ml. So and next we have mass to volume percentage, right? So we have mass to volume percentage. Now mass means that is W, mass means W by volume means V. So above will be always the formula is mass of the solute, and this will be in what? In gram, and volume of the total volume of the solution, this will be in ml. So 10% W by V means 10 gram of the solute will be dissolved in 100 ml of the solution, V, so it is volume. Next let's go to parts per million. Parts per million is also a concentration terms which we will use when the solute is present in very trace amount, very small amount. So it is also same mass of the solute, and here it is also mass of the solution. When it is mass, it was always in gram and into 10 to the power 6, not 100. Okay, so now we are going to calculate the mole fraction. Mole fraction is denoted by the symbol chi. So mole fraction, see, we have binary solution, we have two components, and we have let's consider A and B. So if I want to find for each component mole fraction of the solute, above will be always the ratio of moles. Okay, so mole of the solute, since here it is solute, it will be also solute by total moles, that means solute plus solvent. Again, moles of the solvent, see here it is solvent, so we will put here solvent, moles of the solvent and total mole, that means solute, total moles of the solute plus that means solute plus moles of the solvent. Okay, so these are the concentration terms. Again we have total mole fraction is always equal to 1. Okay, total mole fraction is always equal to 1. So we have two components, solute plus solvent. So mole fraction of the solute plus mole fraction of the solvent is equal to 1. Total mole fraction is equal to 1. Suppose if we have n components, then x1 plus x2 plus xn, so it is also equal to 1. We have again another term called molarity. It is denoted by the symbol capital M. Okay, molarity is defined as the number of moles of solute present in the or dissolved in the per liter of the solution. Okay, always remember below will be volume of the solution, that also in liter. Okay, fixed. Number of moles of solute, above will be number of moles of solute, below will be always volume of the solution in liter. So mole means, again we can express it, we can break these terms, mass by molar mass, both will be solute. Okay, and volume of the solution we can also write in this form, and also we can write in this form. If the volume is given in ml, then we will always convert it into liter by dividing with 1000, so it becomes it will change into this. Okay, because if it is given in ml, we will put by that value by 1000, so 1000 will go above, so just 1000. So this is the short formula by using mass of the solute by W, molar mass of the solute by M, then volume of the solution in V. Okay, so this is your formula. You can use any out of this given. You have to learn this as well as you have to learn this. Okay, because sometimes if the question numericals gives in terms of moles, then you have to use this. Okay, so the unit of molarity is what unit? Just learn the formula, number of moles, so mole, below is your liter, so per liter, so mole is unit is of molarity is mole per liter. Okay, so now it is defined as the number of moles of solute, so mole, dissolved per liter of the solution, so this is per liter. Okay, next we have another term, that is molarity. Okay, it is denoted by the symbol small m. Molality is defined as the number of moles of solute, okay, by, this time it will not be volume, this time it will be mass. In the previous case, in case of molarity, it was mass of volume of the solution. Now in this case, it will be mass of the solvent, not solution. That just, so since it is mass, it will be in kg. Okay, so in this way we will break the terms again. So mass of the solute, molar mass of the solute, by mass of the solvent in gram. It is given in gram, we will put 1000. If it is given in kg, then 1 by mass of the solvent only. Okay, so the unit of molarity is unit of m is, see, number of moles of solute, so it is mole. Then it is mass of the solvent, so it is per kg. Okay, mole per kg, or we can write small m. Okay, so these are the terms. By knowing these concentration terms, we will be able to know the exact amount of solute or the exact amount of composition present in the solution.